Okay, can a secretary and treasurer, okay, be selected? Okay, if that makes sense. So in how many ways can a treasurer and secretary be selected? Or let's say, or I suppose, as O.D. Morris uses, is elected. Okay, how many ways can they be elected? Okay, there's 6 nominations for secretary, there's 5 nominations for treasurer. We'll assume that they're all different people, that you can only be nominated for either secretary or treasurer, that you can't be nominated for both. Okay, so let's have a look at this. So in how many ways can this particular committee be selected? Yeah, okay. Now, so if you think about it here, yeah, okay, the position of secretary, there's only one position, okay? There's only one secretary, okay? There's a secretary and there's a treasurer, okay? There's a secretary and a treasurer for this particular committee, okay? Well, how many choices have you got for the secretary? Well, you've got 6 nominations, so there's 6 possible people that could be the secretary, so 6 goes in there. And how many nominations have you got for treasurer? Well, there's only 5 nominations for treasurer, so you've got 5 possibilities there. So in total, there is 30 possible. There's 30 possibilities for creating a secretary treasurer pair, if that makes sense. Okay. Let's have a look at another example. Okay. Let's say example 3. Okay. So example 3, okay. Let's say a code consists of a letter of the alphabet. Okay. So a code consists, okay, of a letter, okay, of the alphabet, okay, followed by a three-digit number. Okay, there we go. So followed by a 3-digit number. Okay, from the digits 1 to 9. Okay, if that makes sense. Okay, and let's say some examples. Could be a code that would be B32323 as an example. Yeah. Okay. So we want to know how many codes can be selected. Yeah. Okay. Now we're going to assume in this particular case that now after you choose the letter, you're going to choose a digit, you're going to choose another digit, and you're going to choose another digit. Okay. So if you think about it for the letters, so we have a letter, okay, followed by a digit, followed by a digit, followed by a digit. Okay. And the question is, how many possibilities could you have? Yeah, okay. So if, once again, this is rule number 2, we have a certain number of possibilities for the first selection, a certain number of possibilities for the second selection, the third selection, and the fourth selection. So how many letters are there in the alphabet? Well, there's 26 letters. So there's 26 possibilities for the letter. So there's 26 possibilities there. What about the digits? Well, the digits 1 to 9 are, it's not 0 to 9, don't forget, it's 1 to 9, so there's actually only 9 digits there. So you could have 9 possibilities for the first digit. And then you could have 9 possibilities for the second digit, and you could have 9 possibilities for the third digit, if that makes sense. Okay. So in this particular situation here, okay, there would be 26 times 9 times 9 times 9, okay, which gives us 18,954 possible combinations, or possible, let's say, possible codes in this particular case. Okay. Okay. What about if we restrict it? Let's say a restriction, okay, that no digit, okay, occurs twice, occurs more than once. Okay, so no digit occurs more than once. So let's think about it now. Okay, so now we still have a letter. The code needs to be a letter followed by a digit, followed by a digit, followed by a digit. Okay. Now you've got 26 choices for the first. 26 choices for the first letter of the code. You have 9 choices. You have 9 choices for I suppose you have 9 choices for the first digit. Okay. Then you have, well, because if whatever we choose for the first one can't occur as the second one, okay, so you have only 8 choices for the second digit, and whatever's occurred here can't occur in the next one, okay, so you have only 7 choices here. Okay, so once again, this is the second rule at play here. Okay, this is the first bit here, sort of the first rule. Okay, times the times, I suppose. Well, sorry, it's like really the first rule here, where we have the same number of objects being selected for each one of the digits. That part of the question is okay. Whereas in this particular case here, we sort of have the second rule at play here. We have a different number of possible objects for the first selection, different number of possible objects for the second, the third, and the fourth selection, which gives us a total number of ways of doing this. Okay, gives us 26 times 9 times 8 times 7, which gives us 13,100. So that gives us 13,104 possible codes that we could select, if that makes sense. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video just dealing with some examples of permutations and their calculations. Yeah, I hope that this was in some way helpful. I will put up more videos on examples of permutations after this one. Once again, thank you for watching, and I hope that this was in some way helpful for you. Okay, bye bye.